Dr. Nihar Ranjan Sahu, senior scientist in State Pollution Control Board, Odisha, Bhubaneswar, and he will deliver his lecture on air quality assessment, and that will be highly beneficial for the audience. So now I request Professor Meera Das to introduce our today's speaker, Professor Das.
Thank you. Greetings to our honorable speaker of today's webinar, Dr. Nihar Ranjan Sahu, Professor Sujata Mishra, head of the department, and all the faculty members, research scholars, and postgraduate students of Department of Chemistry. It's a great pleasure to introduce Dr. Nihar Ranjan Sahu. He obtained his BTech degree in mechanical engineering in 1987 from UC Burla, Sambalpur University, and his MTech degree in chemical engineering with industrial pollution abatement as a specialization from University of Roorkee. Now it is IIT Roorkee in 1995. Then he obtained PhD from IIT Kharagpur for his research in market-based policy in India for climate change mitigation from Department of Industrial and Systems Engineering. And he did a course in planning for environmental preservation from Hokkaido Institute of Environmental Science, Japan in 1998. In the year 2000, he was selected as British Chevening Scholar and did a diploma in environmental management from University of Manchester and University of Bradford, UK. He is working in State Pollution Control Board, Odisha, since 1988 and currently holds the post of Chief Environmental Engineer in the board. And during his tenure, he has handled several projects in association with World Bank and GIZ, that is an international enterprise owned by German federal government, operating in many fields across more than 130 countries, on particularly on environmental management, sustainability, and climate change. And he has many research articles in high-indexed peer-reviewed international journals to his credit. Now I welcome you, Dr. Sahu, to deliver the lecture on air quality assessment. Please.
Uh, thank you, Meera Madam, for the kind words. Respected head of the department, uh, Dr. Sujata Mishra, Madam. Respected all faculty members of the chemistry department of IT SOA University. My dear fellow students, researchers, it's in fact a privilege on my part to interact with you, to deliver, to share something which I think will be beneficial to you. What I have prepared a presentation which I will be sharing with you in a few minutes. This is about air quality management or assessment of air quality. Uh, what exactly we do with various air quality monitoring and air quality, this scientific analysis of various air quality parameters. We know a little bit of that, but in this presentation, I think we will delve a little deeper into the aspects of air quality assessment. And I invite all kinds of questions because I'd like to make it more interactive. So anybody has got any questions coming up, we can discuss on that. I'm not very sure whether I'll be able to uh, you know uh, uh, satisfy or reply to all the questions that will be raised. But certainly, I will try to do that to the maximum possible extent. The reason being that the air quality assessment is a evolving field, particularly in an evolving field in India. So, just spare a moment. Let me share the presentation. Now, whether my screen is visible?
No, sir.
No, no, sir.
Yes. Now, is it visible?
No, sir.
Just a moment.
हाँ मैडम कौन कहले गोटे मिनट हाँ
Now, is it visible?
Yes, sir.
Now,
Yes,
now,
sir. It
now
is
it is
visible.
visible.
Okay, so thank you. Sorry about that. So today I will talk about the source apportionment of particulate matter in ambient air. You must be many of you must be aware of what is this air quality and what air quality monitoring how air quality monitoring is done. But I will try to show some unseen aspects of this air quality management. You know that air quality, air pollution is a global concern, and very recently you might have coming across various news items coming up daily. In fact, a day before yesterday and day before yesterday, it was making highlights on World Health Organization. Making modifying its air quality norm and standards and guidelines. It has made things more stringent. The air quality parameters, they have specified that for greater health in view of, particularly in view of the COVID pandemic situation, they have imposed a stricter guideline, stricter norm for various air quality parameters. The reason being that there are 1.2 million deaths are in India are attributable to air pollution that was estimated in 2017. In fact, recently you must have come across another news item that by the University of Chicago, their research have shown that an average Indian in an urban city, it loses about 5 to 7 years of its life because of poor air quality. That is because in terms of particulate matter PM 2.5. So, I mean, the idea of my telling this is that the air pollution actually has, in fact, have become attained a very frightening dimension in India, and particularly if you look at the various air polluting cities in the world, perhaps India has the highest number of cities having poor air quality. So, I mean, the news about poor air quality in Delhi in winters, particularly post Diwali, makes the headline for weeks together. In fact, the cities in Odisha is also not, very far behind, though we are much better than the big cities, mega cities like Delhi and Bombay and places like that. But then we still are, our air quality is still poorer than the national ambient air quality standard. It is the norm that is stipulated by the government of India. So the idea is that air pollution is a national problem. The air pollution is, it's now in India's top of one of the top five agenda in the country, and there are several programs going on, like the National Clean Air Program, National Air Quality Monitoring Program. They are all going with an objective, going on with an objective of giving a clean air. Cleaning the air that we breathe in every city. So it is in this background we have chosen this topic. We have chosen this topic of air quality assessment. And so, just to start with, we in India we are having about 132 cities. We call it non-attainment cities, but the air quality do not meet the standards. And in fact, year on year, the number of cities, not such non-attainment cities, are increasing. 2 years back, Odisha had six non-attainment cities. Now we have seven non-attainment cities. So therefore, we can understand, though even though a lot of measures are being taken, but the air quality continue to worsen year after year, despite all the actions that is being taken for cleaning up the air. Now these are the cities. You can have a look at this: Raurkela, Balasore, Talcher, Angul, Kalinganagar, Cuttack, and Bhubaneswar. These are you can see that all our cities are located on the north and northeast part of the state, and we have a sort of national knowledge network. National knowledge network is a network of various research institutions across the country, with IIT Kanpur as the nodal agency. So it is the IIT Kanpur has picked up various agencies in different states that provide technical assistance and knowledge assistance to the non-attainment cities, the city administrations. Like for example, in Odisha we have IIT Bhubaneswar, NIT Raurkela, Utkal University. They are the knowledge partners of various non-attainment cities of Cuttack, Bhubaneswar, Anpur, Kalinganagar, and Talcher. So, so with this background, just I take a brief, a short time to explain where do our air quality lie. When we're talking of air quality, like any kind of any health report. For example, in a person we a doctor, and the doctor prescribes that you should monitor these are the monitor certain parameters in your, maybe in your blood parameters, maybe your different parameters. Similarly, in the air quality, what we monitor particulate matter. We monitor two types of particulate matter. One is PM10, that is particulate matter with an aerodynamic diameter of 10 micron or less, and then PM 2.5, particulate matter 2.5, that is the mean particle diameter of 2.5 micron or less. The idea is like that means these are the smaller particles we are talking about. The particulate matter, the particles which are larger than 10 micron, they are they pose least risk to human health. For example, the particles being very large, even if it becomes airborne, it settles very quickly, and even if somebody inhales it, then it gets stuck on the nostrils. It really doesn't get into the lungs. But PM10 being smaller in size, it goes into the lungs, but it can be respirated back. It can come out because the particle size is large. PM 2.5, that's the particle of great health concern, because PM 2.5 almost behaves like a gas. It goes deeper into the lungs and remains there and doesn't come out. That means if the PM 2.5 concentration in the ambient air is higher, then what happens over a period of time? It gets deposited in the lungs, and the problem is, like for example, when someone smokes cigarette, they also inhale a good amount of PM 2.5, but then they have a choice. The smoker has a choice to quit smoking or something. But when it remains in the air, in the ambient air, then we have no choice. We don't have any choice. We simply we have to inhale it, and then allow our lungs to get damaged. So these are some of the. I have shown the non-attainment cities. The red line, straight line that shows the national ambient air quality standards. That is for PM10 it is 60 microgram, and for PM2.5 it is 40 microgram. you can see that PM10 it exceeds the standard by almost 40 to 50% in different seasons. I mean, the different colored bars, it indicates month wise. So you can see the winter months are more polluted than the summer months and monsoon, quite naturally, because the monsoon, the rain, it cleanses it scavenges the atmosphere. So therefore, you can see that in monsoon we have a better air quality. Similarly, PM 2.5 and 10, and they exhibit almost similar behavior. Now, year on year, if you look at various PM 10 level, you can see that it always remains, I mean, the annual average always remains above the norm. Now, let us. This is something very basic thing that we know. Perhaps we nowadays there are several mobile apps. Even we have set up some display boards at various traffic junctions that tells us the air quality. Now the question is, for a common man, it's fine. They simply know that, well, the air quality today is good or today is bad, whatever. But now the real problem starts, because our job doesn't end here. It's not, our job is not to tell everyone that this is the air quality. The job is to really to do something about it so that the air quality improves. Now the question is how to do it. We first need to understand. Now let us look at the graph on the left hand side and start asking the questions that is shown on the right hand side. That is, what quantitative information does this convey to the policymaker and regulators? What does it say? I mean, the kind of graph that we see on the left, what does it convey? It conveys one thing. It conveys that this is more than the standard. Are we being able to make out whether it is increasing, whether it is decreasing, or is it possible? I mean, whether it is, it does give that some information that whether the meteorological conditions or weather conditions have got any influence on the air quality. So basically, suppose if I want to regulate the air quality, if I want to reduce it, if I want to make the air clean, then what should I do? I mean, so when we ask these questions, then perhaps this graph that we see on the screen doesn't provide an answer, or doesn't provide give us a clue what has to be done and what can be done to improve the air quality. Now, similar is the case of PM 2.5. We can ask the same question, that what happens in PM 2.5. You see that, for example, the gray line is for Bhubaneswar. So Bhubaneswar PM 2.5 is PM 2.5 are more than the standard. The red line is the standard norm. So I mean, we still can. I mean, we can ponder over the same questions, that what we can do. Let us take a look at another air quality data graph that we get. We have several continuous ambient air quality monitoring stations. So this one, this continuous ambient air quality monitoring station have been operating in Talcher, and it's being operated by the State Pollution Control Board. And this is a data for last 2 years. And you see the behavior of the PM10 data. Then here also again we can ask similar questions. How much change is taking place due to meteorological forcing? Whether the changes, I mean, we see that the air quality is improving over a period of time. Then again it is going up and again coming down and so on. So whether is it, now question is whether the coming up or improvement that we see in the air quality is because of a kind of a meteorological conditions, or it is because of any air quality improvement program that is being implemented is because of that, or whether the policy that is being taken, for example, I mean, most popular policy were taken in Delhi, like odd even policy. odd even policy and things like that. So how do we really know that whether, for example, in Delhi, the Delhi government imposed that odd even policy that on one day only vehicles with odd number registration number, they will book and they will fly on the road, and the next day the even number